So class, yesterday we have done the integrated rate equation for zero order reaction. So now today we will do for the first order. But before starting that first order, let me explain the graph for this zero order. If we plot a graph of concentration and time, then for the zero order reaction, it will start from something like this point, okay, and it will decrease like this, okay. So this slope will be considered as, yes, the slope will give the value of k, okay. Negative slope, that is going to be negative slope, will give you the value of k. Got it? And here it is initial, we can say that the initial concentration, and this one you can say that the final concentration, whatever, okay. And this is starting with the 0 and time increasing. So you can say this is the final concentration, or whatever the at which position we will take, that can be the final concentration. So it comes inclined downward, what we say, line, okay. So now it starts with the first order reaction, and for the first order reaction, the same way we will do the same integration formula we will follow. The first thing, basic thing, we are supposed to write the equation, and here we will. So for first order reaction, we can write R change into product, and if we write the reaction rate law expression, so as in that previous one also, I have explained rate of reaction with the small r. Can you see? Let me just take it out. This is small r, okay. So here also we will mention small r for the rate, okay. So we can write this small r is equal to rate constant and reactant concentration. What is the reactant over here? D. R. Got it? So now let's do. So if for the rate for this r, if we want to write the differential rate equation, what we will write? We will write, yes, tell me. D. This is the change in concentration upon time, isn't it? So change in concentration for what? We will take the reactant. So dr upon dt, can I write like this? Is equal to kr. Okay. Now next thing, I will take this dt over here and this r over here. So it will be dr upon r is equal to minus k dt. This minus sign also I am taking on this side, isn't it? Now on integrating both sides, taking the lower and upper limit. So this is dr upon r is equal to minus k is constant, so it will come out, and this will be dt. Yes. So now there is a formula in that differential in that integration. Dr upon r integration is ln r. Got it? Natural logarithm. This is the formula you have to learn. You should know. Integration of dr upon r is ln r. There is a formula in that integration you can do. And here minus k and small dt will integrate it and to give t, isn't it? Like this. And along with this, there will be a constant, integrational constant. The c is integrational constant we are using over here. So now, if we take the lower limit and higher limit, suppose that lower limit at t is equal to 0 time if we take. So obviously this r will be r naught, isn't it? So let's put the value of these things in equation 1. So this will be ln r naught is equal to, this becomes 0, t is equal to 0 if I'll put over here. So this will be 0 and we'll get this c. Any problem in this? Okay. Now from this equation 2, put the value of c in this equation 1. So now put the value of c in equation 1. So this will be ln r minus kt, or instead of c we will write ln r naught. Isn't it clear? Now both the things are, so let it be like this. Kt will come on this side and this will be ln r naught minus ln r. Okay, can I write like this? Now, this is log m minus log n. We know that, isn't it? Log m minus log n. So what it will be? Log m upon n. Isn't it like this? Yes. And we know that ln में कोई value given नहीं होती है. We cannot find the value in ln. So what we will do, ln is equal to, we will convert it into log. Ln is equal to 2.303 log. Yes. So what we will write? Let it be kt is equal to, can we write 2.303, and this is this is log r naught upon r. Got it here? And this can be generalized as a formula, and that for first order reaction this formula will be generalized as, see, this is, got it? So I can write k here is equal to 2.303 t log, this is initial upon the left. This is the generalized formula. See how it comes. This k will remain here. T I'm taking in this side, 2.303 upon t it will be log. This one is initial, isn't it? And r is the concentration at t is equal to t time. So that means whatever initial में से जो घट गया, initial में से जो खत्म हो गया, मतलब so जो बच गया है, that is this r. Okay. So this formula can be generalized like k is equal to 2.303 upon t log initial upon left. This is the rate constant, integrated rate constant for the first order reaction, and this formula is very much important, and the numerical from this of this topic will be asked from this formula only. So this is called integrated rate constant for first order reaction. Okay dear, got it? Now the next heading, we will do the numerical afterwards. First let me complete this half-life. Okay, or this is half-life period, we can say. So see, as the name suggests, half-life. Yes. So how can we define the time? The time taken to convert the reactant exactly half of its initial concentration. Exactly half of its initial concentration. Got it here? So initially, if it is R, so whatever the time is taken to convert the concentration, to convert this concentration R to R by 2, that is called half-life. Okay, denoted by T half. Denoted by T half as a subscript. Clear? So let's find half-life for the zero order, and then we will find for the first order. So half-life for zero order. Zero order. Let's write the formula first. The formula we have done yesterday, K is equal to initial minus final, yani left upon T. You can check this. Here we got this, isn't it? So like this. So now if T is equal to T half, then obviously this R will be initial ka half, isn't it? Now put the value and we will find K is equal to R naught minus R naught upon 2 upon T half. So we can take it T half here, and this will be R naught upon 2K, isn't it? Just solve it, you will get it. Just a simple maths. Done. This is for zero order reaction. Now, if we have to find for the first order reaction, half-life period for first order. Just start with the formula that integrated rate law is K is equal to 2.303 upon T log initial upon left, like this. This was the formula. Yes, we can check from this. Okay, so now if T is equal to T half, so obviously this R will be R naught upon 2. Now put the value. So T I'm putting as a T half and taking it like this. Yes, so this will be 2.303 and this K will come over here. Log, this is R naught, and instead of R what we will write? R naught upon 2. So this will go up, isn't it? Now it will be cancelled and this will left with the T half is equal to 2.303 upon K log 2. And we know the value of log 2. Log 2 is 0.3010. So T half will be equal to 2.303 into 0.3010. From where this 3010 came? Log 2 value. Got it? Upon K. And once you will multiply these things, you will get this 0.693 upon K. So you got the formula T half is equal to 0.693 upon K. This is the formula of half-life for the first order reaction. So now you have both the formula. Just check this. You can see this formula for zero order and this for first order. So what observation you can observe from there? See, for zero order reaction, the T half is depending upon the initial concentration, isn't it? Okay, but for the first order reaction, this is not depending. T half is not depending upon the initial concentration. Whatever the initial concentration, it will remain same. As for example, हम कर सकते हैं like carbon disintegration is always a first order reaction. Okay, so the question can be asked that the half-life for the 100 gram carbon is 5770 years. Okay, half-life for the carbon is 5770 years for 100 gram. What will be T half for 10 gram of carbon? Can you tell me? Think of it. Okay, if we plot a graph between for first order reaction, this will be ln r and then it will be time. So this will also give you the negative slope, but the only difference is here in for the zero order it was r and it was that initial concentration. Here it will be ln r naught. Okay, that is, and the slope, negative slope, will give you the k value. Okay, similarly if I will take this graph can also be like this. If I will take ln r naught upon r with respect to time, then it will be a straight like inclined line in an increasing way, and this slope will be positive slope, it will be, and this slope will be the value of k upon 2.303. You can check from the graph, you know how we have to draw the graph. Y is equal to mx plus c formula based. Okay, so after the graph we have practice few questions based on the first order reaction. Okay, so this is the first question. Let's start with this. The initial concentration of N2O5, and these are the things like this is very important questions. One this and another question is also, this is from your NCERT only. Okay, so the initial concentration of N2O5 in the following first order reaction, N2O5 change into like this, was 1.24 into 10 to the minus 2 mole per liter at 318 Kelvin. The concentration of N2O5 after 60 minutes was this. Calculate the rate constant for the reaction. So how to, it's so simple question. We don't have to, like, we know that for first order reaction we have a formula What is that formula? You all know that this is K is equal to 2.303 upon T log initial upon left, isn't it? So what you have to find? You have to find the rate constant. That means K you have to find. Time is given initial concentration, that is 1 mole per liter, 60-minute time is given. Okay, initial concentration was given this and the final concentration was given this. So it's so simple, you put the value and get the answer. So if I will put this 2.303 upon like T is given 60 minutes. Okay, so 60 minutes, and since nothing is said, so we will keep it in minute only. Okay, log initial was given. What is this initial? Check this, 1.24 into 10 to the power minus 2 upon what is the afterward, like left concentration. This is 0.20, so let it be 0.20 into 10 to the power minus 2 mole per liter. So this will be solved 2.303 upon 60, and this will be log what? 0.6 and 2, 62, isn't it? It will remain like 6.2. Okay, so take the value of 6.2 and you will put just put the value and calculate it. This is somewhere, and then we will put the answer. So log 6.2 we have to check. I'm also not learning this, so you just I will put the value afterwards. Okay, now the next question. The next question is here, and this is actually a very important question. I don't confused in that. So this is very important question. The following data, if it is in gaseous form and like this, so we can't keep the first law directly. We cannot keep this formula. Okay, what is the formula? How to get the formula? We have to take out. We have to find it like this. Like the reaction, this is the following data were obtained during the first order thermal decomposition of N2O5 gas at constant volume. 2N2O5 gas change into 2N2O4 gas plus O2, and rate constant you have to find. So what you have to do, this is, you just write you have to find that after 100 minutes what will be the concentration of N2O5 left. Okay, what will be the pressure? So this is 2N2O4, N2O5 change into 2N2O4 and plus O2. Yes, all are in gaseous form. So pressure we will find in terms of pressure. So at T is equal to 0 time, initial concentration, initial pressure is given 0.5. Okay, so at that time obviously the product will be 0. After few times, suppose that at T is equal to 100 second ही देख लेते हैं. So some portion will be this is total pressure given, isn't it? Total pressure, that means reactant and product both are there. So after 100 seconds, some portion of this pressure will be converted into this, isn't it? So we will apply the equilibrium formula. For 2 mole, it will be minus 2x, isn't it? And this is 2, so it will also form 2x, and here it will be 1 mole, so we will make it x mole only. Got it? And according to question, if we see this, so at T is equal to 100 second, the total pressure will be, total pressure कितना होगा? We will find 0.5 minus 2x plus 2x plus x, isn't it? This is the way we were using in the chemical equilibrium. Okay, so now the total pressure value is given at 100 degree. What it is? 0.512. So we will keep it 0.512 is equal to, this will be cancelled and it will be 0.5 plus x. So we will find that x is equal to 0.512 minus 0.5. So it will be 0.012, isn't it? 0.012 atm. Is it like that or something? This is 00, no? So 12, yes. Got it? Now, what you have to do, now you can use the formula. So what is that formula? We have that K is equal to 2.303 Why we are using first order? Because it is mentioned first order here. Upon T log initial pressure. Let me write in this way. Initial pressure upon left pressure. And you should know this thing, that in this equation there is no use of product. We have to just concentrate on reactant only. So this is 2.303 upon T log initial pressure was, what is this, 0.5, isn't it? And the left pressure, many of you can do this mistake, and they actually do this the left pressure they will write like this. This is not the left pressure, my dear, this is total pressure. Okay, so left pressure is what? This is the left pressure, 0.5 minus 2x. Got it? Now you got the value of 2x over here, so put the value 2.303 upon T, and this is log 0.5 minus upon 0.5 minus 2 into 0.012, and once you will solve, you will get this 2.303. Let me write the value of T is 100 second log 0.5, and after solving this you will get somewhat 0.476. okay, now solve this thing, and after solving this you will get the value to like it is coming it is NCERT question, so I can write the answer from there. I know this is 4.98 into 10 to the power minus 4 per second. Okay, got it? And 1 second here also you can find the value of log 6.2, and the final answer, it is coming like 0.0304 per minute. Okay, I will put the value in the PDF. I will put the value of log 6.2. okay, so okay class, after this I have written 3 more questions, and that I'm going to give you as a you have to do as a homework. And this is the question, please write down this one. Next is this, and the third one is this. Okay, so just try to give a try for this, and then after I will explain in the video. That's it for today. Thank you class.